Hi everyone. In this mini lecture, I'm going to talk about how to solve the problems, the type of problems you would get for question 5 on the exam. So the first one I want to talk about is balance after years, where you're given a number of years, you're given the percent interest rate, and you're giving a starting balance, right? So you want to write a function or define a function to determine how many or how much the bank balance is going to be after Y years with a given balance of start balance and a given annual interest rate of percent rate, right? And it's compounded annually, which means that you get, let's say, as an example, if you had $500 and you have a 3% interest rate, after the first year, you'll have $515, and the 3% will be the next year's interest will be applied to the 515 instead of the 500, right? So if you were doing always on the principal, that would be considered simple interest, right? So the function that's going to determine basically what the balance is after what next year's balance is going to be this one right here that you have. Your accumulator is going to represent your current balance. Num is going to be the number of years you've kept the balance in for, and it's not actually going to matter in the calculation for determining what the next year's balance is going to be. So each time you're just going to take whatever the current balance is and add the current balance times the interest rate over 100. Right, so let's actually fill out the table for the inputs y equals 5, a percent rate of 3, and a start balance of 500. So here item is representing the year number, right? So we would say for a starting balance of 500 after, at year 0, right, your starting balance is 500, so year 0 should have a balance of 500, right? And then we use this function to get the next row in the table, or to get the accumulator that's in the next row in the table. So we plug in this 500 into ACC, right? We plug in the 0 for num, but again, it really doesn't matter what num is because the output, you can see, does not have num in it. And we just calculate this. So this is 500 plus 500 times the percent rate of 3 over 100. So it's 500 plus 500 times 3 over 100. The 500 times 3 over 100 is done first, right? Order of operations would say you do multiplication before addition. So it's just going to be 500 times 3 over 100, which is 15, and you're going to add that to the 500, so your ACC1 is going to be 515, right? Okay, now that you have 515 here, you're going to have 515 go into the accumulator and 1 go into the number. Again, the number is not used here, so we just do the 515 plus 515 times 3 over 100. And that will be 530.45, right? And we keep going, right? So then 530.45 becomes the new accumulator, 2 becomes the new number, and again, we just plug in the 530.45, and we will get the next value here, scroll down a little, of 546.3635. And finally, we'll do this. We'll plug this value into the accumulator, and we'll get the 562.754405. And then the last time around, it's going to plug that in again, and you will get your final answer here of 579.63703715. Okay, so the point I want to make here is that you can see that each time the accumulator is going to be the balance after this many years, right? So we started it that the accumulator was the balance after 0 years, right? So we made sure it's true at the beginning. And then every time we go up to the next year, we're getting the next year's balance, right? So if this is the balance after year 0, then this will be the balance after year 1, this will be the balance after year 2, right? Because each year we're getting the next year balance, so every time item goes up by 1, the balance will go to the next year balance. So we're preserving that relationship that the accumulator is always the balance after the number of years that's given over here. right? So this is, again, scrolling down a little, this is going to be the balance after num years, right? So we said item here is our num, right? And this is important. Before you actually fill out the code, right, you want to have this table and you want to know the relationship between the columns, because that's going to tell you when you want to stop, for instance. Like, for instance, if you say, oh, you know, I'm going to y of 5, right? I want to do this, I want to repeat this 5 times, or I want to get the balance after 5 years. You say, oh, do I stop at 4 or do I stop at 5, right? Well, you know that if 4 is the balance after 4 years, then you would want to stop here when item is 4, because you would say, okay, this is the balance after 4 years, and we want to plug in the 4 and then this for the accumulator, whatever the balance is after 4 years, and we want to get the next year balance or the 5th year balance as our result, right? So that tells you would want to stop at 4 and not 5, because if you stopped at 5, right? When I say stop at 5, it's like you go one more time. But if you stopped at 5, then you would really be getting the 6th year balance, right? And you could also see that if you're starting at 0 instead of 1, then you do really go 0 to 4, because there are 5 integers here from 0 to 4. If you instead went with 1, right, then you would go 1 to 5, right? Because again, you want to repeat this function 5 times. But what's nice, again, with starting with 0 is it preserves that relationship that this is the balance after this many years, right? So if you started this at 1, right, this would always be behind. So this would be the balance after this minus 1 years, right? So when you get to 4, it would be the balance after 4 minus 1 years, or 3 years, right? So that gives you an idea of how to set the table up, and some motivation for why we set it up the way we did, given that there were other options here. But again, you can set it up differently. That's just going to change the code that you write, right? So once you have the table, you can use that to determine what you should put in when you're using repeat for every item and show steps, starting with ACC of, okay? So the starting with ACC of is going to be whatever you have in your first row, first column. That's going to be for all of these problems, right? So here you would be starting it with, you see you don't have 500 as one of the options. So I said it's first row, first column, so what's going on? But remember, this has to work, this function has to work for other start balances, right? So here you have to say, well, what was that 500, right? That 500 was my starting balance, right? So if I change this, if start balance changed to 600, this would change to 600. So remember, you want to figure out what the pattern is here. You know, you want to get something that works for not just one example, but for many examples, right? So I give the example, right? If you were trying to write a function to compute the square root and you only computed the square root of 2, imagine having this on a calculator, right? So the person now wants to calculate the square root of 5, and you say, wait, no, you can't calculate the square root of 5 yet. Give me back this calculator and I'll reprogram it for you so it can calculate the square root of 5, right? That wouldn't be very useful. So especially then when they say, okay, now I want to calculate the square root of 7. Okay, you say, give it back to me. I'm going to reprogram it again so it calculates the square root of 7. So you can see that doesn't really work. So you just see what the pattern here is. And the pattern, again, is, what are you going to put in here? You're always going to put what your starting balance is, right? So this is what you want to put for your starting with ACC of, right? Okay, so the next thing would be what you actually start your range at. And here, regardless of what the starting value is, regardless of just what your start balance is, what the percent rate is, what your y is, you're always going to start this at 0, right? Because you're always putting your accumulator as your starting balance, and you want to have this relationship that the accumulator always represents the balance after this many years, right? The thing in this column represents the balance you have after whatever you have in this column that many years. So since the 0 doesn't change, you should just be starting range at 0, right? Because this is the array, when you call repeat for every item and show steps, this is the array that it's calling it on, And so what it's going to do is it's going to start with whatever the first value or the 0th value in the array is, which also happens to be 0, right? So it's just going to be this, right? This number gets plugged in for num first. Okay, so start balance gets plugged in for accumulator, num gets plugged in for 0. The next thing is to figure out when are we going to end. And remember what I said here is we wanted to end here at 4, even though our y was 5, if I can select this. If our y is 5, we still wanted to end at 4, right? And if our y were 10, where would we want to end? Right, well, we go 0 to 9. That would be repeating it 10 times, right? So we would want, this would, if we have this relationship holding true, when this is 9, this would be the balance after 9 years, right? So to get the balance after 10 years, right, it would do this last time. I would say, okay, it's 9 years, and now I'm going to get the balance one more time to get the 10th year. So in general, whatever y is, since we're starting at 0 and not 1, we would want to go to y minus 1. But remember, the way the range works is you don't actually go up to the number that you want to go. You have to basically say that range is going to stop 1 before. So if you want to go up to 4, you're going to have to put in 5. And so what that's basically saying is rather than putting in y minus 1, you would have to put y. Right? And again, this has to be completely general. So what I just said is when it was 10, you would want to do 9. When it was 5, you would want to do 4. So in general, whatever y is, whatever the number of years is, you want to go to 1 less than that. Right? So that would mean if you want to go to y minus 1, right, you have to give range 1 more, so you do y minus 1 plus 1, which gives you your y. Now again, for this problem, since it doesn't actually use num, you could have just done anything that, like for instance, if it's y is 5, instead of going 0 to 4, you could have gone 1 to 5 or 2 to 6, right? So anything that you would be using, you'd be doing where it would be repeated 5 times. So anything that would have an array of length 5. So if I just made it starting at 1, right, instead of doing 0 to y, I would go 1 to y plus 1, because then I would be ending at 5, and so I would have to give range 6. Right? So again, it really just depends on the relationship that you have between these columns. Right? And here what you'll see is how you go from one accumulator and number to the next. This is what tells you, again, how to go from this row to the next row to the next row. And that's just what we said. You take the accumulator, which is the current balance, and add the current balance times the percent rate over 100 to get the next year's balance. Okay. So here we don't actually, as I said, use the item. Other problems we might, right? Okay, so let's talk about factorial next here. So factorial, the factorial of an integer, of a positive integer, we'll say, is just going to be defined as the product of the numbers from 1 to that integer. So